Hi, I am Muhammad Asyraf. Today I will explain about linear ODE equation. So the equation that we get is dy over dx equal x to the power of 2 plus 3xy over 3x to the power of 2. So the step 1 is we rewrite the equation in linear form and find px and qx. So we just insert the equation in our MATLAB. Bracket x to the power of 2 plus 3 multiply x multiply y bracket over 3 multiply x to the power of 2 bracket. So we run the MATLAB. And we get minus y over x equal 1 over 3. So this answer is already in linear equation, in linear form. So we just compare in our manual calculation. So in our manual calculation, it same. In line 13 and 15, I write the value of px and qx because it will use in other step. So for px we get minus 1 over x, while qx we get 1 over 3.
Assalamualaikum, my name is Muhammad Fitri Najmi bin Muhammad Khalid, and I'm going to be explaining for step number 2, which is finding the integration factor I. To find integrating factor of px, we need to know the value of px, which is in this case negative 1 over x. From there we can use exponent. We can use this command exponent and integral of px dx, and then we display the integrating factor, which is 1 over x.
Stay focused, people.
My name is Muhammad Amirul bin Sidirman, and with my matrix card number CE2300079. For this question, I would like to explain about the question 1 part B. So the given question is we need to solve the given first order differential equation using the linear ODE equation. As you can see, on the left side is the manual calculation, and on the right side is the MATLAB simulation. So let's compare these two things. Okay, so on the left side, by using the linear ODE equation, we need to form it in a linear form. So dy over dx minus y over x equals to 1 over 3. So our px is negative y over x, and our qx is 1 over 3. So by knowing that, we can find the integrating factor, which is the equation is I equals to exponent integration of px dx. So our px is negative 1 over x, and by inserting the values of px into the equation, so it will be exponent integrate of negative 1 over x dx, and then after integrating we will get x exponent negative ln x. So the exponent and the ln can be cut off, and then the final answer is x to the power of 1. Now let's see the MATLAB simulation. So if we run here, so as you can see on the step 2, find the integration factor, which is I equals to exponent integration of px dx. We have inserted the values, so the integration factor of I is 1 over x. So we can see it is the same to the manual calculation. Okay, we carry on to the next one, which is finding the y times I. So the formula for y times I is y times I equals to integration of qx multiplied by I dx. So our qx we have already known, which is 1 over x, and our I is 1 over 3. So as you can see on the left side, y times I equals to 1 over 3 integration of 1 over x dx. So y times I equals to 1 over 3 ln x. After integrating the 1 over x, we will get ln x plus c. So we only want the value of y. So as you can see on the left side here, y equals to 1 over 3 ln x plus c. We only want the y. So we have already known that I is 1 over x. So by moving the I, which is 1 over x, to the right side, we will get the answer y equals to 1 over 3 ln x plus c over 1 over x. So we can also simplify it by 2 y equals to x 1 over 3 ln x plus c. So that is the manual calculation. So we carry on onto the simulation. On the step 3, the new equation, as you can see, the answer on the right side, the new equation is y over x equals to 1 over 3x, and the formula equation, which is the y, equals to c plus log x over 3 over x. So after rearranging it, c will equals to y over x minus log x plus 3. So, but it is not the same because on the left side, we have make the y as the subject, and on the simulation, it shows the c as the subject. So by comparing it, it is actually the same, but just for the manual calculation, this is the answer, and the MATLAB simulation, this is the answer. But basically, it is just the same. It is just the it is not the same as the simulation and the manual calculation. And I think that is all from me. I would like to pass this on to continue to homogeneous ODE equations for part 2 to Fitri. Assalamualaikum and thank you.
Moving on to step number 4, which is applying initial condition to find the particular solution. First of all, we need to use the command subs and put the rearrange equation, this one, y over x minus log x over 3, which is equals to c, and then the variables that we want to substitute, which is the initial condition, x equals to 1 and y equals to 1, x equals to 1 and y is equals to 1, and then we display the result of the constant c, which is c equals to 1, and then we can get the final answer, y over x minus log x over 3 equals to 1. That's the final answer and the particular solution.